よろしくお願いします。So yeah, I'm going to talk about. I'm a computational artist, and I'm going to talk about what I've been doing in the last couple of years only, which is mostly about AI. I'm doing a PhD at Goldsmiths, which. So really, the title of my talk is "Machines That Learn." What do they know? Do they know things? Let's find out. And primarily, what I'm more interested in is what can we learn from machines that learn. So like I said, I'm mostly going to talk... Oh, is it possible to turn the lights off, by the way? Anyone? Is it possible to turn the lights off? So I'm going to... Oh, yeah. Excellent. Thanks. I'm going to talk mostly about what I've been doing in the last 3 or 4 years. So before that, I want to spend a few minutes talking about what I was doing before that. So what you're seeing is work from about 15 years ago to about 2014. I'm a visual artist, and I write software to create my artworks. I started out really interested in animation, in moving image, like abstract animation, abstract film. And I was very not happy with the tools available to me as an animator. I didn't like having to work with timelines. I didn't like having to work with keyframes and rendering. So I moved into writing software to create real-time, interactive, computational systems that I could use kind of like a visual instrument. I like the metaphor of playing a piano, where you take an action, you hear a sound, and you respond to it. So I was interested in creating systems to achieve this. Also, I was interested in breaking away from the screen, what is now known as expanded animation. So creating moving images in 3D space, hacking physical reality, whether it's working with robotics or lights, time-lapse, etc. So I've been interested in using emerging technologies initially as a medium. It was always a way of finding ways of using the technology to enhance our ability to creatively express ourselves. But then gradually I started becoming more interested in the technology itself as a subject matter. How technology enhances the individual, how it affects the way we think, how it affects us as a society, how it affects culture, and how it affects ritual, how it affects our values, how it affects our ethics, and how it even affects religion and all those kind of things. And this is how I started getting into more and more into AI, artificial intelligence, because I started trying to think of systems that could be more autonomous, not just very dumb computational systems, but systems that had some level of autonomy that we could collaborate with. My PhD at Goldsmiths is a technical one. It's a computer science PhD. Today I'm going to talk less about the computer science aspects, but more about my own arts practice. And the relationship is I do the research, the technical research, and then that sparks lots of questions around, ranging from philosophical questions, also to how I could use them in actual artworks. So I will talk more about the latter today. So some of you probably may be familiar with this aesthetic. This is Google's Deep Dream that they released in 2015. A couple of programmers from Google accidentally discovered this technique in 2015, and it was quite big on the internet, and everyone hates it because everyone's seen it so much. I really, really love Deep Dream, but it's not the aesthetics that I love. What I really love is the poetry, the conceptual poetry happening behind the scenes. So super quickly to explain what happens, this is a neural network that's been trained to recognize and classify images like cats and dogs and birds and lizards, etc. And when it's presented with an image such as my face, it tries to classify it. And what Deep Dream, what the algorithm does is, it says, whatever it is that you think you're seeing, modify the image such that you maximize those activations. So it's trying to maximize the the activation inside the neural network and to modify the image to achieve this. So in a way, this is a bit like us looking at a cloud and thinking that we see a bird or a rabbit, and then we draw what we think we see. And then we look at what we drew, and we draw something again based on what we think we see. So metaphorically, that's quite interesting. But the reason why I really love Deep Dream is because as soon as Deep Dream came out, everybody was complaining, oh, I'm fed up of puppy slugs, I'm fed up of bird lizards. But actually, there are no bird lizards here, there are no puppy slugs. All there is are textures, which are abstract. It's noise with a particular distribution. But when we look at this, we try to make meaning. We project onto this what we already know. And this is exactly what Deep Dream is doing. So in a way, we are completing this loop of meaning making. So this is what I'm really interested in using machine learning for, using it as a way to reflect on how we make sense of the world and to use machine bias as a metaphor for human bias. Because effectively, this is what goes into a neural network such as this, just pure white noise. And the neural network takes it on a journey through multiple dimensions and transformations in space and time, because that's what a neural network does. And it produces this. Interestingly, William also mentioned the Rorschach Test yesterday. And we look at this and we write stories because that's what we do. That's what we've always done. It's how we survive in the wild. We look around us, we yearn for structure, and we make stuff up, and then we believe them. And even these sentences that I'm saying right now, you are making sense of in your own way, based on your own life philosophies, based on what you've read, based on what you've seen. And it's impossible for me to know exactly what you're thinking and what you're feeling, even with these words that I'm saying. And this is kind of like the basis of my practice right now. This is a neural network that is making live predictions on a webcam input. So there's a lot of motivations behind this piece. At one level, it ties in with what I said at the very beginning about trying to create computational systems that we can use to enhance our own creative expression in a real-time interactive manner, kind of like an instrument. And my PhD at Goldsmiths is also about how can we use deep learning, or the current state-of-the-art deep learning algorithms in a real-time interactive manner, because it's generally not designed to be like that. So this is the highest level motivation. This neural network has been trained on about 20,000 images, about 5,000 waves, 5,000 fire, 5,000 clouds, and 5,000 flowers. But the deeper level motivation behind this piece, again, also is to highlight how this neural network, which has only seen these things when it looks at me playing with stuff on my desk, and it's trying to understand, it's trying to make sense of what it's seeing, it can only see what it's seen before. It can only make sense of the world through the filter of its prior experience, just like us. This is a similar piece. It's from the same series, Learning to See. This one is trained on images that I scraped from the Hubble Space Telescope. So images, photos of galaxies and nebulas, etc. It has the same motivations. It's basically the same, it's the same line of work. But there's a few additional motivations behind this one. One is, when I said that this is trained on images from the Space Hubble Telescope, we might be inclined to think that this network knows about space. It knows what space looks like. And in a way it does. It's quite amazing how it learns how to construct nebulas and galaxies and all these things. But this isn't actually what space looks like, because what comes from Hubble aren't these photographs. It's just streams of data that then a team of humans, engineers and artists and scientists, come together and they interpret this data and they decide what space actually looks like. So they use their own vision of what they think space should look like to construct these photos so that we can look and have a picture. I don't even know if we are able to fathom what galaxies, which are hundreds of thousands of light years across, I don't even know if we could visualize that. So actually this neural network is not learning what space looks like. It's learning what we think space should look like. And we forget that. We assume that this is ground truth, but actually it's not. There's human bias already in the data that we're feeding it. And the other motivation behind this particular work is I like to constantly remind myself that the atoms in my body and the atoms in your body and in everything around us was forged in the hearts of stars and supernova billions of light years away, billions of years ago.
This is a world of wonders.
I'd like to talk about a VR piece. This is not about AI at all, but it's about perception. It really gets to the heart of the works that I was talking about earlier. And I say it's a VR piece, but it uses VR technology, but it's about as far from VR as I think one could actually imagine. And I'd like to talk a little bit about the motivations behind it. Our eyes are often likened to cameras. There's this idea that light falls on the retina, and then we form an image, and that image gets sent to the brain for processing. But that's not how seeing happens at all. In the times of the ancient Greeks, it used to be thought that seeing happens because we shoot rays out of our eyes, and that these rays would coalesce with the material outside and connected to our body would create this sensation of seeing. It's called the extramission theory of vision. It's a really beautiful theory, I think. Of course, it's wrong. That's not how seeing happens at all. Light does fall on the retina. But what I do like about the extramission theory of vision is it really underlines this idea that seeing is an active process, that it's not passive. You have to take actions. You have to look in places, because obviously the part of the eye that's actually high resolution and full color is the fovea, which is really tiny. It's about the size of 2 thumbnails at arm's length. And the reason why we can create this giant image in front of us is because the eyes are constantly saccading, scanning the scene 2 or 3 times a second, which we know from experiments in the 50s and 60s that Alfred Yarbus, a Russian scientist, did with this, what looks like a torture device. And he even found that when you ask people questions about a particular scene, like how old are these people, what are they talking about, what happened, how long was the man away, how affluent are they, etc., it affects the way that people scan the scene. So in a way, the actions that you take are dependent on the meaning that you're seeking to take from the scene in front of you. So these are the motivations behind this particular work. And the final bit of information I'd like to give is this phenomenon known as binocular rivalry, which has been known for hundreds of years. It's been studied scientifically. It's also been studied artistically a little bit as well, not a lot, surprisingly. And the idea is if you give, so normally stereo vision happens when the 2 eyes receive monocularly similar images, where it's the same scene but from slightly different perspectives. But if you give the 2 eyes monocularly dissimilar images, so images which are radically different, then the brain is unable to integrate the 2 signals to create a single cohesive percept. So what happens is, in your mind's eye, your conscious awareness is of something similar to this image on the left. I say something similar because it will be different for every individual. And it's impossible for anybody to know what the other person sees. Of course, this is how seeing always is, but we forget that. We always assume that we experience the world in the same way. So these are the motivations. Oh yeah, another thing, if the 2 images are static, like if the left eye sees that red image and the right eye sees the blue image, the percept that you receive in your conscious awareness is animated. It moves, it swipes, and you can't control this. And it's impossible for me to know what that is. So I won't go through all this text. This is kind of like a summary of what I just said. But the key thing I want to underline is the last point, which is even when presented with the same information, everybody will experience something unique, and it's impossible for anybody else to understand that. And I'm interested in this on a perceptual level, in the way we see the world, but really the main motivation is a response to what seems to be a growing amount of polarization, political and social, at least in my home country of Turkey, in the UK where I live with Brexit, in the States we can see this, where beyond going perceptual, we're unable to really try to understand people with other points of view, and this seems to be creating this growing divide. So the piece is called Fight. It's a VR installation that looks a little bit like this, where you're invited to come sit down on this seat and go on a journey. It's a kind of spiritual journey. It's very abstract. The images are a bit like this, very geometric, very simple. Obviously, seeing it like this, you're not getting the effect at all, but I'll just skip for that reason. One interesting thing I do want to say is, so it's a 10-minute linear experience. So like at this point in time, wherever you look is deformed. So this is trying to underline, again, the idea that seeing is an active process, that the act of looking and the actions that you take affect the meaning that you take. But the other thing is that there's no rivalry at this stage. Both eyes are seeing the same thing. So it feels like there's an external world. It seems like the picture is outside of your body. As rivalry comes in like this, the brain is unable to integrate the two signals. The picture physically feels like it's inside your head. It doesn't feel like you're seeing something mixed out here. It feels like something mixed inside your head, which is again a reminder that what we see is actually constructed inside the head. I've also done a lot of work with text models. There are these algorithms which you can take and give it like a huge corpus of text. And these algorithms know nothing about language. They don't know English. They don't know anything. But going through this text, they can learn semantic relationships between words. These are called word embedding models. Quite famous ones are Word2Vec and Glove. And what they learn is they learn a high-dimensional space, and they learn coordinates for positions for words in this high-dimensional space, such that there are relationships between these words. For example, a very famous one, so this is not my research at all, this is very famous Google research, that there's a gender vector, there's a direction, so that the vector from the word king to queen is the same or similar to the vector from man to woman. And this means you can do arithmetic operations on words like queen minus king plus man, and the model gives you the word woman. Or it learns about tenses, swam minus swimming plus walking, and it will give you walked. Or it learns country and capital relationships. So Madrid minus Spain plus Italy gives you Rome. So this is all stuff that the neural network learns unsupervised, in the sense that we don't give it any information, we just give it a huge corpus of text, and it learns these things. So I was curious, well, what else has it learned? So I wrote a Twitter bot that picks a couple of random words, and then a couple of random mathematical operations, does the operations, and then tweets the results. And again, what I find most fascinating is, where do you draw the line between understanding what the machine has learnt versus our own interpretations? For example, I don't know, nature minus God is dynamics. Like, does that actually mean anything? Or am I projecting myself back onto it when I look at those results? I wrote actually a big essay on this that you can find if you just Google word of math. I also did another one that looks particularly at gender, because there's this another famous result, which is doctor minus man plus woman, and the network gives nurse. Because I should say that this model is trained on Google, on news, on 100 billion words of news. So it's basically reflecting everything that it's learned from how society uses these words. I'm going to go very quickly over this. There's a lot more in the essay I wrote about this. And I'd like to very quickly skim through some other motivations that I have, interests in AI, which according to the internet looks like this, very blue and shiny. I'm interested in the rise of AI. This is a trend graph for the term AI in Google News after a few years of big data and that relationship, because it should come as no surprise that we have AI after having lots of big data. One angle is I like the metaphor of consciousness as evolution solution to dealing with big data. The rise of intelligence in biology after the emergence of vision during the Cambrian explosion. Again, I wrote an essay on this as well, which, oops, what happened there? Which you can read online. But the main reason I'm also interested in is, the other reason why we have AI is because those who are investing in AI are those who rely on it, those who rely on making sense of big data, whether it's the Facebooks, the Googles, or the NSA, the GCHQ. And this is why a lot of the technology is surveillance related. And I think it's very fair to say that if World War I gave us analog computers, and World War II gave us digital computers, and the Cold War gave us internet, that it's the mass surveillance of this supposed war on terror and internet business models which is giving us deep learning. But I think the main reason I'm really interested in AI can be summarized by Florence Nightingale. To understand God's thoughts, we must study statistics, for these are the measure of his purpose. I'm also really interested in how religions and faiths and deities have evolved over millennia, and how the deities and the overseers have always co-evolved with society's needs and the modes of subsistence and their values and social structures. And now, as we lose our spiritual sensibilities and become more technologically oriented and submit to technology, we are building a digital god for our digital culture. But it doesn't even end there. We used to offload our cognitive processes and memories to devices, to rocks, to paper, to computers. But we used to keep these devices within on our body, or we had physical access to them. But now we use these things as portals. We don't even offload our cognitive processes to devices that we own, but we offload it to the cloud of all places, which is where God lives. But it goes even beyond that. It used to be that the churches of the old were the commissioners of art. They were the inspirers, the storytellers and history makers, and the commissioners and the funders. But now we have our technology giants moving into that space too. So inspired by all of this, in 2014 I wrote a poem, a collaboration with Google. Not people working at Google, but actual Google, the search engine. So this is more a collection of prayers, actually, because we have a very intimate collection with the cloud. We confide in it, we confess to it, we share secrets that we wouldn't share with our closest friends and family. So as you can see, the basic idea is I write a few things, and then the collective consciousness of the internet completes the query. And this is the poem. I did this every year, and it's really fascinating to see how it changes and how it reflects the trends of the year. Like around 2015, 2016, I think gender and identity came into it, which was very fascinating. So I had this realization a few years ago, oh, why is it skipping? That all the work I've ever done is about two things, waves and God. And luckily quantum mechanics unifies the two. And I think when I use the term waves, what I mean is the patterns in nature which we humans have managed to somehow formulate into equations and theories, and sometimes mathematics that we find elegant and beautiful. And when I use the term God, I think what I mean is those mysterious aspects of nature which we have yet to understand, and the lengths that we'll go to, the stories we'll tell, to try and make sense of it all. And when I use the term quantum mechanics, I think I'm referring to the fringes of human knowledge, which we empirically or mathematically can understand, but we have yet to really understand what it means on a larger scale. So this is one kind of waves, a particular kind of waves that I am fascinated by. I grew up by the sea, and I can spend days just sitting there. This is my meditation, basically. This is another kind of waves. This is a series of work called Simple Harmonic Motion that I started in 2011 as an exploration into complexity from simplicity. So incredibly simple rules giving rise to complex behavior, which is pretty much the foundation of everything that we observe in nature. But there's something beyond that, which is here, when you look at this, you might see lots of moving parts. This might look relatively complicated, but it's actually a very, very, very simple rule that's driving all of this. But what I find fascinating is if you watch this long enough, you will start reducing it down to something simple again, to a simple rule. But chances are you're not going to reduce it down to the simple rule that I programmed in. You're going to find higher levels of simplicity. So we have complexity emerging from simplicity, but then we have higher order simplicity emerging from complexity. And in a way, this again describes the way that we do science, because chemistry is a simplification of the complication that came from physics. And so is biology is a simplification of chemistry, and psychology, sociology, economics. These are all emergent behavior that we try to reduce. Again, we're yearning for structure, and we're finding these higher order rules that have emerged from the complexity. So I did a lot of versions of this, various different scales. What's this? Oh yeah, I was fortunate enough to do it with 80 robotic spotlights at a palace. I'll skip this video, but the video that I do like is this one, which is what happens when you stare straight up at the sky. These are the patterns that are projected back onto the cloud, which is where God lives, remember. I did a live performance with 16 drummers. I think I'm short on time, so I'm going to skip some of these works. How much? 5 minutes. Okay, great, thanks. I'll quickly talk about this then. Is this running? So this is the opposite of what I just showed, in the sense that the previous piece, simple harmonic motion, was incredibly simple. It's just one very, very simple rule, which is giving rise to complex behavior. And you are struggling to find the simplicity in it. This is very, very complicated. This is a live action, this is a camera, feed being fed into a computer, there's a dancer, there's fluid simulations going on, there's lots of complex calculus. So from my point of view as a programmer, the rules that go into this are very complicated. But when you look at it, you just see a person straight away. So it's quite astonishing how well we've evolved to recognize the human form amongst all of this noise. And what's particularly interesting is that if you look at this, you maybe don't see a person. You just see an abstract blob. It's only through movements that you're able to identify the person. And then there'll be times where you lose the person, but then you find it again. And now you know where the arms are, where the head is, where the legs are. And then as you lose it again, you can still, in your head, simulate, and then you can latch onto it again. Because actually the way, well, the one current dominant hypothesis is on how we make sense of the world is through predictions. We're constantly running feed-forward models in our head, we're making simulations, and we're trying to match our predictions with what we observe. Which brings me on to this project called Equilibrium, which I made in 2014. Initially, it's about ecosystems and the delicate balance that they hang in. So here there's millions of objects which are oscillating furiously. It looks static, but it's actually dynamic because there's an overall balance here. It's in homeostasis. But when you touch this system, you upset those forces and it falls apart and it starts oscillating on a much grander scale. And if you leave it alone, it will hopefully eventually find a new point of equilibrium. And like I said, this was initially inspired by a trip to Madagascar and the very delicate ecosystem there. But again, this also explains the climate, financial markets, politics, social trends, lots of systems, including our own brain, which is also a nonlinear dynamical system. And it's also thought that one perspective at looking at how the brain works is, or at least how it tries to make sense of the world, is that it's trying to find these points of equilibrium, that all the signals coming in from outside or from within the body are upsetting this balance, and this system is trying to find a new homeostasis, and that act itself is what learning or cognition is. So I've probably only got about a minute left. I'm going to skip a few of these projects and get to deep meditations, which is, this is when I showed it at Goldsmiths, and this is at the Kinninji Temple. And once again, I'd like to thank the organizers for giving me and the other artists the incredible opportunity to show work at this incredible place. So very quickly, I'll just describe the piece. It's very, very slow moving. It's about 1 hour long. I suggest at least 5, 10, 15 minutes. You don't have to watch the whole hour. But it's basically a meditation on life, nature, the universe, and our subjective experience of it. It's a controlled exploration of a neural network that's been trained on over 100,000 images of these abstract concepts. I basically scraped the internet, or particularly Flickr and other sources, for images that were tagged with words like life, love, art, faith, ritual, worship, God. These things don't have clearly defined visual representations, so I collected what do people think that these things look like, and then fed it to the neural network. So the neural network has learned what people think these things look like. But then once it goes through the neural network, it produces generally very abstract images. So this is a particular point where it's able to create a flower quite, that's quite representational. But then it goes through places where it becomes really abstract. And I really love the way different people construct stories when they're presented with these images. I had one friend who said, oh, I can see a heart, I can see a brain, I can see that. And I'm like, that's you, I didn't put that there. So in a way, this is a meditation of the machine because it's an exploration of its inner world, but it's also a kind of duet with the observer. I think I'm out of time, so I'll just leave it there. One last thing I'll say, the sound is also generated by another neural network that I scraped YouTube for hours of religious and spiritual chants and prayers and rituals from all over the world. And arigatou gozaimasu. Thanks.